Section 2. Track, or more commonly known as toe settings, should be such that the road wheels run parallel to the direction of travel when the vehicle is being driven in a straight-ahead position. The terms toe out and toe in refer to the deviation from parallel when the vehicle is stationary with the steering centralized. Toe out is the usual setting for the front wheels in front-wheel drive vehicles, and toe in for the front wheels in rear-wheel driven vehicles. Misalignment in track or toe settings can generally be recognized by the wear pattern shown here. This is often easier to feel than see. If the setting straight ahead is incorrect, the toe out on turns may also be incorrect and should be checked. Any of the following damaged components could cause misalignment in track or toe and therefore lead to tyre wear. Track rod bent. Steering rack misaligned. Ball joint on track rod worn. Wheel bearing loose or worn. Drop arm from steering box bent. So let's see why. In the correct position, with the steering wheel centralized, a line drawn from the lower swivel points through to the track rod ball joints will meet when extended on the center line of the vehicle. If one or more components are damaged or worn, then tyre scrubbing or feathering will occur. Today's modern tyre can cope with very slight deviations in alignment, but to achieve maximum tyre life, precise handling and safety, the settings should be as close to those specified as possible. Rear wheels are just as important to vehicle handling as the front wheels. If tracking is incorrectly set or has sustained damage, the same wear pattern can occur and tyre life will be reduced. The attitude of the whole vehicle is affected, especially in the straight-ahead position. In this case, the wheels on the rear don't rotate in their true path, but are dragged along the road. Alignment checks must be carried out to eliminate such faults, and faulty components replaced. If heavy loads are carried in such cases, tyre life is reduced even more dramatically. Camber. Camber is designed to give true rolling stability. Camber can be set by either reclining the stub axle downwards by altering the angle of the front suspension leg, or by moving the ball joint position on the suspension leg or on the wishbone. If the road wheel is inclined outwards at the top, the camber is positive. If the wheel is inclined inwards at the top, then the camber is negative. Incorrect camber settings can be identified by wear on one side of the tyre. Excessive wear on the outer edge indicates too much positive camber, as seen here. Where a long downward deflection of the suspension leg occurs, the camber attitude can alter from positive to negative. Obviously, worn or damaged components can influence the camber setting. Therefore, such items as road springs, shock absorbers, wishbones and their mountings, as well as wheel bearings and ball joints, must be considered where fault diagnosis is undertaken. CASTOR. CASTOR is generally used to enable the steering to self-center. This obviously helps the driver to feel the straight-ahead position. As a vehicle is turned into a bend, a torque has to be applied to the steering because the preset CASTOR tries to keep the front wheels pointing in a straight line. Most vehicles have leading or positive CASTOR. This is achieved by inclining the McPherson strut forward at the bottom so that the wheel is behind the projected line through the swivel points as shown. Any alteration to this angle is felt in one of two ways. Too much leading CASTOR will cause the steering to become heavy and also cause the steering to wobble. Too much trailing CASTOR will allow the steering to wander because the self-centering action will be cancelled out. CASTOR checks must always be carried out after accident damage repairs. Section 3. Wheel balance problems. Wheel balance is another area that can be affected by faulty or badly worn components. A faulty shock absorber is one such cause, because the bumps in the road surface cannot be fully absorbed, and therefore the tyre has to cope with them. This will cause the tyre to wear in a series of flats around the tread. Similarly, a weak or broken road spring will cause the same wear pattern. Many vibration problems can be overcome by ensuring that the wheel and tyre assembly does not have excessive run-out and lift. This can sometimes be eliminated by refitting the tyre correctly onto one wheel and then balancing the whole assembly in accordance with the tyre manufacturer's instructions. Summary. You've seen from the sections covered that there are many ways in which the handling and comfort of the vehicle can be affected. Individual geometry figures have not been quoted, as this would take too long. For correct settings, consult the appropriate workshop manual. Last of all, you must consider the following points before attempting any checks or corrections. The vehicle must stand on level ground. Tyres must be of the recommended size and type and be inflated to their correct pressures. The vehicle should not be loaded, or if it is, the load should not exceed the manufacturer's recommendations and be evenly distributed. A full mechanical inspection of the suspension must be carried out to identify any worn or damaged components. Measuring equipment must be in good working order and zeroed prior to checking. The appropriate figures must be to hand for correct reference. Always remember that tyre regulations are very specific in quantifying the amount of tread that a tyre must have. This should always be borne in mind when examining a tyre and advising the customer.